Lesson 4.4 in Calculus BC. I just want to show you one additional question that is in the homework, and if we don't discuss this, there will definitely be a lot of questions. Take a look at example 10. We've got a limit as x goes to negative infinity. We have x plus the square root of x squared plus 2x. And it's so very tempting to want to do end behavior here. The problem is we're wrestling with this end behavior. Really, end behavior is going to help us out primarily as we're looking at rational functions. So, of course, as we look at this, as we substitute in an x here, you can see it looks like we're going to negative infinity, and the square root of x squared here, negative infinity squared, would be positive infinity squared. It's very tempting to think that the square root of infinity squared would just be infinity, and negative infinity plus infinity would go to 0. We can't do that. What you want to do is, if you ever have an expression like this, you want to get a rational expression. And tell you what you see with these square roots is it's very typical at this point to go ahead and actually multiply through by the conjugate. Conjugates, by the way, you had a plus b times a minus b. The whole reason for doing that is to get a squared minus b squared. And you can think, how in the world could having a squared minus b squared help us? Well, if you get rid of square roots, that's going to help you immensely, and it's going to make the problem that much easier. Even better still, now that we're going to have a rational expression right here, a fraction, an algebraic fraction, we're going to get a lot more help in regards to being able to do end behavior. So our a squared, well, that's going to be x squared, minus, well, b squared. Well, my gosh, when you take b and you square that, you're just going to have the square root go away. And very quickly then, let's just distribute that negative and clean this up a little bit. So we'll have the limit as x goes to negative infinity of x squared minus an x squared minus a 2x. And down below, we've got this maybe a little ugly expression right here. You can see your x squared and your minus x squared are going to be canceling out. Now, one thing that I do want to point out to you is that the square root of x squared, of course, is really the absolute value of x. And in terms of end behavior, that 2x really doesn't even fit into this description. It's inconsequential. So up on top, I've got a negative 2x, but down below I'll have x minus, well, what is the square root of x squared? Well, it's just the absolute value of x. Now, I can keep going, and the really cool thing is at this point, pardon me with the screen here, with this point, we can really benefit from getting a little bit of help with the absolute value function. The absolute value function, I'm going to just give you a little bit of a reminder. It was x when x was greater than or equal to 0, and opposite x when x is less than 0. But paying attention to this limit in particular, you can see that x is negative. Like as x is going to negative infinity, x is approaching numbers like negative 1 trillion and so forth. So as we continue to clean this up a little bit, I guess what you're seeing is this radical x squared with the absolute value of x. Both of these terms in the denominator have x to the first, but this absolute value of x is really opposite of x. So it only is going to take another moment to clean this up. We're almost done. We'll have negative 2x all over a 2x down below. That goes to negative 1. So some of the homework problems will have an expression like what we began with. Get a rational expression. You're probably going to have to multiply by the conjugate. And once you do that, you'll be able to see where we're headed. Hope this helps.